For this lesson, we're going to see how we can make reflections. And we're going to have the spinning cube from a previous lesson, which happens to be my personal favorite spinning cube. And then we'll have a reflective floor, or reflective surface, which will show a reflection of the cube. The basic strategy for reflection will be to just draw the cube, and then to draw a second copy of the cube, which is reflected vertically, and then using alpha blending to draw the floor on top of the screen. So let's actually see what happens if we do this. This actually isn't quite right, because you'll see that the reflected copy of the cube is leaking off of the bottom of this floor. And in order to fix this, we're actually going to have to use a new concept called the stencil buffer. The stencil buffer is just basically some amount of memory set aside for each pixel. And in this case, we're only using 1 bit. What we're going to do is we're going to figure out all of the pixels where the floor is being drawn, and set each pixel in the buffer, in the stencil buffer, to be equal to 1 at each of those pixels. Then we're going to draw the reflected copy of the cube, but only draw it where the stencil buffer pixels are 1. So that's all that we really have to do to fix it. If I uncomment out this section of code, which I was using to show you what happens when we don't use the stencil buffer, then you'll see that actually the reflection looks right. It'll fix that problem where we had the cube leaking off of the bottom. So we actually have a reflective looking surface here once we use the stencil buffer. Now let's take a look at the code and see how we can do this. We have at the top some constants, the length of each side of the box, the length of each side of the floor, and the height of the cube off of the floor. We have a drawCube function, which draws the cube, and we have a drawFloor function, which draws the floor. And I'm going to focus on the drawScene function. The first difference between this particular drawScene function and drawScene functions that we've seen in other programs is this GL stencil buffer bit. Before we just had GL clear and then this part right here, but we're adding in GL stencil buffer bit because we need to clear the stencil buffer every time we call drawScene. We need to set every pixel in the stencil buffer to be equal to 0. So then we have over here where we draw the normal copy of the cube, which is just using a call to draw cube. And then we're going to set some stuff on the stencil buffer. So we need to call GL enable GL stencil test to start using the stencil buffer. And again, we're going to set every pixel covered by the floor to be equal to 1 in the stencil buffer. So we're going to call GL color mask 0000 because we don't want anything that we do to show up on the screen. We're just working with the stencil buffer. We don't want any of this to show up on the screen. Then we're going to disable depth testing because we really don't need it. We'll just disable it in order to speed things up a little bit. Then we call GL stencil func GL always 1 1. And there's actually a lot of interesting stuff that you can do with stencil buffers, but I'll only tell you what you need to know for reflections. So this GL stencil func call just basically makes it so that the stencil test will always pass. And I'll actually explain about the stencil test a little later. Then we call GL stencil op, GL keep, GL replace, which makes it so that every time a pixel is drawn to a particular location, every time we draw a particular pixel, it'll set the pixel in the stencil buffer to be equal to 1. So then we call drawFloor, which is going to draw the floor, but it's not drawing it to the screen, it's drawing it to the stencil buffer. It's setting every pixel in the stencil buffer where the floor is to be equal to 1. So now we've got the stencil buffer all set up. We have all of the pixels which are covered by the floor equal to 1, and all of the other pixels equal to 0. And we're going to draw the reflected copy of the cube. So first of all, we'll just re-enable drawing to the screen, because we actually want this reflected copy to show up on the screen. We'll re-enable depth testing, and then we'll call GL stencil func GL equal 1 1, which makes it so that the stencil test passes whenever a particular pixel in the stencil buffer is equal to 1. So this test is actually going to be used for drawing the reflected version of the cube. Whenever the test fails, we're just not going to draw the cube, and wherever it passes, that's where we can draw the cube. So in other words, we're only going to draw the reflected copy of the cube where the stencil buffer is equal to 1. Then we call GL stencil op, GL keep, GL keep, GL keep, which makes it so that we don't edit the stencil buffer. So the stencil buffer will not change as we're drawing this reflected copy of the cube. Then we actually draw the reflected copy right here using a call to draw cube. And that takes care of drawing the reflected copy, only where the floor is. Then we disable GL stencil test because we don't want to use the stencil buffer anymore. And we blend the floor onto the screen over here using an opacity of 0.7. And with that code, we have a nice looking reflection right here. We've actually made this cube look like it's reflected across this surface. And that's how you can do reflections in OpenGL.